years, working on MSN, which I still remember and still have an MSN log on, Windows Live, Xbox, Active Directory, Visual Studio, and Forefront Identity Manager, where he plugged into the identity stream, and has been working with Oxford since that time. A great supporter of Oxford. In fact, he presented at our last Identity Summit in May on campus and had a very popular session with great feedback. He's got a lot to talk about today, so I am not going to spend too much more time on this introduction. I'm going to hand it over to Alex. There will be a Q&A at the end of this presentation. I will be monitoring questions that come up during the presentation. Some of them we may go ahead and interrupt Alex and try to get those answered. And if you don't get your question answered during the presentation, we'll try to get to it towards the end. So thanks again for joining us, and without any further ado, Alex, take it away.
All right, good morning. If the Oxford folks give me a quick sound check, make sure I'm all right. Can you guys hear me okay?
You sound great.
Outstanding. All right. So I'm Alex Weinert. I'm a Principal Group Program Manager responsible for Microsoft's Identity Division's Security and Protection team. We do a set of things that include conditional access, multi-factor authentication, risk detection, real-time risk response. We're a little bit of an odd team in that at least in my experience, in most cases, teams that are security focused and response teams are often not the same teams that build product. In my team's sort of unique case, we have investigators and red team, blue team, and response, as well as developing product all kind of under one roof, which gives us a perspective that we think is useful. And we'll talk a little bit about how that works and some of the things we get to see. Before I go any farther, I want to pass back to Steve and let him kind of give the quick overview here, if you'd like to.
Yep, I will blast through this quickly. Oxford Computer Group has been working in the identity space with Microsoft for over 15 years. In that 15 years, we've been Microsoft Partner of the Year 7 times and 3 times winner, 3 years in a row, so a hat trick, I guess. We have more than 600 enterprise projects in the US, UK, Netherlands, and Germany. And one thing that a lot of people don't know about us is we have a very active online training service that trains students worldwide in identity management on the Microsoft platform. We enable businesses with hybrid identities. That is our core specialty, both on-prem and cloud identities, and we do that through cloud enablement, data access and governance, which is affected very directly by what we do, directing authentication services, and identity lifecycle management. And Alex, I don't know if there's a second slide on us. If there is, I'll talk about that and then hand it back to you.
All right. I think the main thing is another slide on upcoming webinars.
Yep, and as I said earlier, this is a monthly webinar. We actually are on a little bit quicker pace than that. RMS, Supercharge RMS with Azure Information Protection is coming up on the 29th. An area that we're pretty excited about, and so are our customers, is Azure B2B and B2C. We're going to have an overview of that on October 13th. And we, on a regular basis, have several webinars that are vertically oriented, and we have yet another one I'm quite excited about in October, Introduction to the EdFi Alliance, which is a data structure, a open source data structure available for K through 12 and even higher ed that layers on top of a lot of the identity work that we do. That's going to be presented by Richard Charlesworth, who is a longtime customer of ours and is a very forward-thinking guy. And we got more in the pipeline, but for now, that's what we're going to share with you.
All right. Okay, so let's dive in. So I have a lot of stuff to cover, and hopefully a fun demo, and we'll see how much we can get through here. There's quite a bit going on here. We'll start with a kind of high-level overview. The main thing here is, and I think most folks are aware of, is that the sort of the tide has turned, and the era of the bound network or the domain join machine, and I can't do any work until I'm at work and I'm at my desk, and that machine was issued by my IT department and controlled in that way, it's kind of over, right? We see now in almost every sector, every customer we have, folks are moving to really a mobile workforce, right? That people can work where they want, when they want, the way they want. And that is giving us a considerable boost in terms of productivity. There was a study in Forbes magazine earlier this year that indicated almost a 25% increase in productivity and 100% improved employee satisfaction out of this sort of paradigm where people can work in the way they want. And I'll do a little confession, right? As this seminar started somewhat early, and traffic in Seattle is somewhat bad, I'm actually doing this from my office in my home, right? Now that ability is a direct example of the mobile workforce. I'm being more productive and having a better experience out of it. So that's good, right? But the old paradigms for how do we do auditing and maintain security and compliance, and whether that's governmental or industrial compliance, are challenged in this world, right? Because you can't simply say, well, I have IPsec or I have a firewall, because those things become meaningless, right? In the world where it's a person on their own device who's logging in from a coffee shop and going to a SaaS app, right? There's no part of that that involves your firewall. So the old world where you say, I need to VPN in to do my work is fundamentally challenged. So, we see that we have security issues with the way people do their work. I'm going to assert that actually, to a large extent, the cloud is going to give us advantages here, and I'll talk about how. But, first of all, we have this mixture of personal and work tasks and devices, and of course, devices can become infected, or they can, have other compliance issues, and this is a place where something like Intune and MDM come in and help you kind of get control of that. We also see more than 80% of employees are using non-approved SaaS apps, so we call these viral app adoption, this model where people are doing what they have to do to become productive. It's important to understand that there's, the security vulnerabilities don't come from people who are most of the time being malicious. They're just trying to get their job done. And one of the things that'll be important as we talk through this is the importance of having a low friction experience. One of the things that I think is a falsehood is this idea that there's a trade-off between friction and security. In other words, if you're going to have a secure environment, it's also going to be a high friction environment. And there's several problems with that. One is that the high friction environment is one that users will avoid like the plague. And so they'll go do what they need to do. They'll just do it in a less secure way, right? So that doesn't really work out. But the other thing is that an environment which is secure, right, is also an environment where you can feel comfortable doing your work and focusing on the work and not worrying about, what were the missteps or the mistakes I've made. So we have actually, I believe, lowered friction and better productivity if we do security right. And we'll talk about ways we can do that. Weak and stolen credentials are really a thing, and we'll talk about these things by the numbers, but the number of passwords that are compromised is truly staggering. And we on my team have come to think of the password as simply the price you pay to get further analysis done. If you don't even have a correct password, there's no point in making the machine systems do the analysis of the login, but the password alone is not really enough, and we want to encourage people to think of it that way, because as you'll see by the numbers here, the password exploits are just extreme. So anyway, what this all boils down to is that when we think about what it means to have a secure, compliant environment in this new world order, right, it's really the assurance that we are talking to the right person that becomes the one thing that we can really key in on, right? We don't know what network you're going to be on. We don't necessarily know what device you're going to be on, but we'd like to pivot back to being sure that we're dealing with a good person who we can validate their identity, and then bind devices to that person. And through having a good control plane and identity, we're able to get back not only to where we were in terms of the old world of security, but actually exceed it. So AAD is, of course, our mechanism for doing that. We're very strong believers in cloud identity. Most of our customers are using some form of hybrid, so they'll have Active Directory on premises, talking through ADFS and going to AAD. And I won't dwell on it very much in this presentation, but we're doing a great deal of work to make the things that we're doing here work in that environment. So, for example, if you're doing ADFS, we are actually assessing things that are in the ADFS token that tell us whether the login is anomalous or whether the user is at risk. If you're using password write-back, we can actually do some of the automatic password change. If you're doing password hash sync, we can do the password analysis that we'll talk about later. We definitely do work in a federated environment, in a hybrid environment. The technology that we're going to talk about in this presentation does rely on the cloud. We simply can't update it and sync it out to you and have it be relevant in that time frame. So this really is a place where the cloud is differentiated, where our intelligence security graph in real time is feeding our security systems and protecting you in real time. So, I wanted to talk just briefly about the landscape. I looked for the most harsh and unforgiving landscape I could find. I think standing on this, jetting lava pool is not too far off in terms of, where we stand in terms of cybersecurity. The one thing that I think, every year I give a set of talks at various conferences, and we very often talk about trends. And we've talked about the trends of things like botnets are getting cheaper, and that the second factor of mobile is becoming increasingly compromised, right? That we see people are attacking the mobile applications, not the mobile applications, but the mobile phones of targets, right? If they're doing targeted takeover. We're seeing various trends, but the trend that I'm seeing right now is this, is that the brazenness of the attacks and the absolute open intent to manipulate things is becoming more obvious, right? And so a good example of this is in our current election, where we're seeing many, many hacks against our election infrastructure, whether it's against, for political gain or, direct hacking of the system. Each of these is a search link, so you can go check it out. They're just Bing searches for the words that they show, but there's a lot of interesting stuff to see there. The other thing that it just isn't news, and so I didn't put it on here, is that, we're seeing just almost on a weekly basis 100 million or so passwords leaked out of sites. So I think the recent ones were Dropbox. LinkedIn was a little bit older. So we're seeing these sites going very, very rapidly. 117 million accounts from LinkedIn, 80 million accounts from Dropbox, and I'm sure I'm forgetting 10. We process these things on an ongoing basis, and we'll talk about the volumes there in a minute. One of the things to realize is that probably one of the most concerning things is that when attackers get residents in a network, they stay resident. And what we've seen in our studies is that it's more than 200 days as a median that attackers reside in the victim's network before detection. And that's one of the main things we're trying to really drive down to zero, right? We want to see that number go to zero. As we get better and better at detection, and we'll talk about some technologies that help do that. We can drive those guys out. But really, on my team, we call ourselves a protection team because our goal is that the attack doesn't ever get a foothold, right? We don't want to let that attacker into your network at all. We do see that most network intrusions are due to compromised user credentials, and that's again something that we can, to a very large extent, prevent those from happening. We just sort of need to get the user's permission to turn on the policies that stop those. The cost involved in various cyber attacks to the global economy is staggering. And I remember when I started really focusing on this 6 or 7 years ago, I was blown away, and I remember giving a talk where I said, and within a few years, the cost of the global economy will be over $5 billion. And it has just gone up, hockey stick style. So we have a tremendous cost, and data breaches obviously are terrifyingly expensive. And if you think about the scope of the breach, depending, if you have something like a targeted or an advanced persistent threat, or a state-sponsored attack, these costs can go substantially higher than a few $1 million. So we have to think about how much more serious the players on the other side are getting. And just as for people who don't know this, it is a business. When you have $500 billion in an economy, which is what the cybercrime economy looks like, you have to think about it in terms of there are really serious players and very serious really companies, whether those are organized crime or state actor that have teams of developers that are working and strategists and the whole thing. Now, the tool that I'm showing here actually has a support policy. You can get email support for it. It costs at the time we did this, I think it was cost around $80 to buy this tool. This one is a password cracker. And so what it does is you can punch in your set of desirable passwords. It has substitution strings, so if you know the username, it'll slam that in. So, if your name is Joe, then this will do Joe123 and Joe888 and all the other common passwords. And they'll just go through a list of known email accounts and do password hammering. When it's done, it'll drop in nice files for you that show you the username password pairs that actually worked. These kinds of things are very common. These build on SDKs, and so we have a whole supply line where we have somebody who ships a developer kit and then somebody else who builds UI over the top of that. We've seen the response times and reaction times on these for when we put in a fix to counter them to be very, very quick. So, all the way up to and including VoIP phone support in terms of the professionalism of what we see here. So it's a very serious game. On our team, we see an awful lot of cybercrime. On a daily basis, and these numbers have been sort of intentionally smooth, so we're not giving exact numbers. What we see here is well north of 10 million attempted account compromises a day. So more than 10 million login events per day are attackers using compromised credentials to try to get into accounts. Now, that's a very small part of a very big number, which is our 14 billion logins a day that we do. But it's still quite an eye-opener to think that we're seeing that many new accounts per day. When you roll that out, that turns into something like 4 billion a year. So we're talking, the population of the planet within a year and a half or so. Now, many of these are rinse and repeat. They attack the same accounts more than once. But the volume here is pretty impressive. We'll identify as an attacking IP, in other words, an IP that has been taken over by an attacker, something like 10,000 IPs a day. We'll shut them down usually just temporarily because IPs are taken over by attackers and not usually just owned by the attackers. And so unless we see persistent traffic on them, we'll open them back up. So somebody will jump on a proxy for a small internet provider, take it over, do an attack, and then get off. And in that time, we can detect a lot of attack patterns. And then we deflect more than 1 million compromise attempts every day, and it's again, more than 1.5 million. When we say that, what we mean is, when we get to the place where we are confident that the attacker actually has the correct password for the account and has some indicator that they know that they have it, that's a compromise. And on the consumer side, we will, on our own, just say, look, you've got to change your password. On the enterprise side, what we're going to talk about in terms of identity protection is really all about setting you up to do the same kind of protection that we do on our consumer side. If you look at, for example, we know an account is compromised, the right thing to do there is put that account through a multi-factor challenge, get confident that we're talking to the right person, and then have them change their password. If you're not confident that a login is a good login, if the location or the device or something else is anomalous, it's nice to challenge that login with a multi-factor off. We lean very heavily on multi-factor off. Our strong preference on this stuff is our apps. We have some cool apps on Android, iOS, and Windows Phone that do push notifications and that do a nice, what we call session approval model that's fairly simple to use, but also very, very secure. So we're not transmitting any kind of password. Everything is cryptographically strong. That whole thing is where we like to see things go. We also support phone, SMS, and email on the consumer side, and phone and SMS on the enterprise side for multi-factor auth. And the reason I harp on it is because we have to be able to challenge, right? And in an enterprise environment, it's very important that you can challenge the user to make sure that you've got the right user. If you haven't set up multi-factor auth, the problem you're going to have is that those challenges turn into work stoppages, and those work stoppages cause screams on the IT help desk, and they cause screams at the executive level, and then your security efforts get shut down. And so this is a place where, again, you have to have low friction to have good security. You're not going to get away with, simply turning off the systems for people. There's a graphic here that I pulled out of the security incident report. There's a large section in that report about how my team does its work and what we do. If you're interested in lots and lots of data and tearing it apart, you can look into that. Put the link at the bottom of the page. This is just showing kind of where, when we talk about shutting down those IP addresses, where those shutdowns happen. So, how do we get all this information? Well, we analyze login trends. We run more than 300 million users a day. We see more than 14 billion logins a day. And the result of those two things, right, is that we have a very good baseline of what normal looks like. We can see normal within a small population. We can see what normal looks like in London at 10 a.m. And then we can look at deviations from normal, right? And that can be used for deviations that indicate that we're dealing with a scripted attack, or deviations from an account's own behavior that say that it's under attack. We do see IP addresses that light up and attack us, and we have all that information. We also have IP reputation systems we can lean on. We have password hammering data, so if accounts are under password guessing attacks, which are rare, but we could still pick up the information from that. We also, when we see those attacks, we can pick up what the common passwords are. And one of the things we do for you under the covers, we don't really talk about it as part of the demo, but one thing that happens under the covers is if you try to use a password in Azure Active Directory that is a common password for attackers to attempt, so something like username 123, right, we'll actually stop you from using that password. Right, so we have what's called dynamic band passwords, and that's really updating on the attack patterns of the day. So we'll see, as we push people away from, say, short passwords, people will go to longer passwords that, the number 4444 to get a 16-character password, just the word 4 repeated 4 times. So those kinds of patterns can come up and be common. The Clever Horse something stable, the one from the XKCD comic, is actually a very common password now, right? People saw the comic and thought, oh, that's a great way. Passphrases for most attacks are no better than passwords. The only counterexample here is if somebody breaches a third-party system. So, for example, and I don't know the details of exactly how Dropbox stored their data, but in that case, if there's a hash, a longer password and a less common password is going to help you. So that's a place where somebody's trying to break a hash, but that's not typically how it's done. And the reason for that is that it's so easy to get accounts from much, much simpler sources. If I want an account in your enterprise, the easiest thing I can do is send out some kind of a blast mail into your email system. Better if I can get somebody who I know what their connections are in the organization, which I can buy from a black market social graph that's available, and then I just send out a phishing mail. And all I need is 2 or 3 people to respond to that phishing mail to get a toehold, right? And then I can start doing things like lateral movement and start moving deeply into the network. So people will give up their passwords. We're seeing also second factor phishing. So for example, SMS, I'll tell you that I'm going to send you a code and ask you to send it back to me. And all I have to do is say, this is from your corporate IT department. And some number of people, it's just statistics, some number of people will respond and give you back that code. So that's an easy way to get things. If I can get malware on your machine, I can do keystroke logging. That's an easy way to get things. But I can also just look at the tens of millions per day of new accounts that are leaking onto the internet, right? And I can do those off of paste bins, and there's various ways to source those. So the effort that it takes to go and do password cracking is largely not worth it, right? There's so many username password pairs essentially circulating and so many easy ways to get them that it's not as big a deal. There's a really good paper, I didn't put a link in here, but I'm happy to source it and give it to OCG later, which is our password guidance paper that talks about the statistics and the studies we've done on this. But the bottom line is that passwords are very weak at this point, and we need a second factor. We also get information from botnet infections. This is a very cool thing that the Digital Crimes Unit does, where they go and they do takedowns of botnet command and controls, and while they're doing that, they have to build up a network view of what the slave nodes are, in other words, what the command-ed botnet nodes are. So if you have a configure-infected machine, they may know it. All that information is passed to us, and we pass it on to our customers through identity protection in terms of letting them know that a device is infected or that a user is being attacked from a botnet. A cool thing about that is that when we first did our public preview, we announced it, we made it available, a customer configured it, and within 20 minutes had picked up a botnet infection in their environment and was on process to cleaning it up, and tweeted about it, which was very nice of them. It's just very kind of them to put it up on Twitter. So it had real efficacy. We've had almost every customer who's tried the product has found an issue and been able to resolve it. So it's showed a lot of efficacy. Leak credentials, we do our own research. We have the attack patterns we see, so we can tell that those credentials are leaked. We also have third-party researchers. We have law enforcement that comes to us, agencies that come to us and give us sets of username and password pairs. Those tend to be older because they're after process. And industry partners. So we work at the Cloud Identity Summit. I got up and spoke with Adam Dawes from Google. Our teams are working together to do combined threat analysis to share data about what kind of patterns and what kind of attacks we're seeing, so that we can protect all of our users more effectively. We compete on a lot of fronts, but user security is a place where we really believe we need to collaborate and tighten things up. And so we're aggressively doing that with Google and others. The effort there has been very fruitful, and so it's a great thing to be able to essentially share. And so what we see, and obviously very, very careful about privacy things, but types of attacks that we see, patterns that we're seeing, we can share what the MOs of the bad guys are. That's been very effective. And then of course users tell us when they've been hacked, and that's another source of data. All in all, we see north of 20 terabytes of data. So how do we process all this stuff? The main thing we have is that if we go through, you think about trying to get through 20 terabytes of data, the army of people it would take to go through and make sense of that data every day is crazy. Even with our analytics tools that we had honed pretty well about 5 years ago, what we found was that our turnaround time to respond to issues was too long. And so we built a machine learning system that is what we really rely on heavily, especially on the consumer side, but increasingly on the enterprise side. Azure Active Directory is effectively, our job is to issue tokens, right? We say, or tickets. We say, if you are a user and you pass over the correct username and password, this is kind of the old world, right? And then we'll give you a ticket back. And that was sort of in the infancy of authentication systems, that was enough, right? You could simply say, I trust that this user is who they are, say they are because they have this password. But as I've mentioned, the password is increasingly weak. So we look at every user as Schrodinger's user, right? The user is a good person and a bad person. We really don't know which until we open the box. So, what do you do about that? Well, you have a developer write some rules that classify logins as either being good or bad, right? And of course, most seem good, most are good, but some seem bad. The problem with this is we don't really know how well the classifier works unless we check its outcomes, right? So what we do is we look through all that information I talked about before, the self-reporting data, the threat data, the behavior analysis, and the terabytes and terabytes of logs that we generate every day. And we go through and we do analytics on that to see that, sometimes we said it seemed good, it really was good, and sometimes we said it seemed bad, it really was bad. And those are our true negatives and true positives, and it's nice to know when you're right, but it's at least as important to know when you were wrong, right? When did we add user friction unnecessarily, or worst, when did we let a bad person get into the system when we shouldn't have? All of that together creates what we call label data, and these are terms of art, so if you're into machine learning, you'll recognize this language. And the label data you could go through with humans, security analysts and developers and operations folks, and kind of go through this process of, figuring out what the classifier did wrong, modifying the classifier, and then deploying a new one. That process in our world, if we go back 5 years, took weeks. And the problem was that the bad guys responded in days. So we automated all of that. And that whole system we call Learner. And the Learner basically goes through and does this analysis, update, and redeployment, and can do it in a course of hours. Now, in practice, we do it typically a couple times a day or once a day, depending on how the models are doing, and we do hand check the models. But the key thing here is that as we look through what the system does for us, it means that if a bad actor introduces a new mode of operation, does a new bad thing, right, the outcomes of that action will be picked up by the learning system and recoded into the classifier within a day. It's a really, really important thing, right? What it means is that the system is handling all the adaptation. So for example, if the browser you use is a strong indicator of fraud today, and we intercept it, and so the bad guys move to a new browser, the fact that the browser was a concern will drop down in the model, and the new browser type will come up in the model. There's over 100 data points that are being assessed on every login, and all of that is happening in less than 10 milliseconds per login. So we do this, literally more than 10 billion times a day. All of that, every decision we make is evaluated post hoc, and all those post hoc analysis go back into retraining the classifier. And this is a day-by-day thing. So this is kind of how the sausage is made. Now, if we go look at it in action, we had an EDU attack about 6 months ago that was pretty interesting, and it was actually in a place where we were training. So a lot of the systems were created in protection of our own assets in Xbox and Outlook and things like that. And as we're bringing them into enterprise, we go through a training process to make sure that the models work correctly. So we were training, and we saw this situation happen where a quarter of this EDU's customers were compromised, or users were compromised. EDU systems tend to have a higher compromise rate and a higher attack rate than most enterprises, because students pass on and they leave the accounts open, and so that can be a big, wide target area, and also the account hygiene for students can be less than ideal. Nonetheless, what we saw was the system picked up a spike in user lockout. So this is times where people were being locked out for trying the wrong password too many times. And we see this all from a single organization. And the suspicious IP activity was really different. Like the in-country IP was very low volume and very, very successful. And then a new country shows up, right? And the new country shows up with a very high volume and mostly failed. So, very bad IP behavior. And again, the system picks this up and alerts us on it. And then here's how the system responds to it. Okay, so we saw a spike, and this whole thing is in the matter of, this whole graph is over the course of about 6 hours. So what we see here is that the attacker does a little test run to test their system, and then they attack with lots and lots of failed logins for a period of time. And that, as the blue line is coming up, what you're seeing is the machine learning system adapting to the attack. Over the course of 6 hours, the large-scale account failures per minute had essentially shut down. And what you're seeing in the blue line is attackers intercepted. So this is places where the accounts were locked out from the attacker, and then we were able to notify the university of what had happened. The automatic response to actually for the accounts that had been compromised, that would have allowed those users to self-help and do their own password reset, at this point wasn't available. But you can see kind of how fast the system can adapt. Okay, so we've talked a lot about statistics. I want to just touch on one quick story, which we try to remember as we go through all these things, that while the numbers are large and staggering, and we can talk about in sort of gross terms, billions of dollars or hundreds of millions of accounts, every one of these account compromises has a very real impact on the human being whose account is compromised, and on the organization where the account is compromised. This is a story from our consumer side. This was a gentleman that actually worked at Microsoft, so we worked with him very closely. And what happened in his case was that initially his landline was compromised. And so most of us are dealing with landline providers that are also our cable providers if there's some kind of bundling going on. In any event, there's a digital system that sits behind the phone system. The POTS is not really happening. The plain old telephone system isn't as vogue as it was. And so that means that you can do things like with a username and password, I can forward phone calls, right? I can do some interesting modifications. I can take phone calls on computers and things like that. And with that information, you can pretend to be somebody that you're not. So, once I go through I own the phone system, right? I can now take that system and use it as a way to break into other systems. So if I call my mobile provider from my landline, they are more likely to believe I am who I say I am. If I have a little bit of social information and I'm calling from your mobile phone number and can control the landline, it starts to be very convincing as I go down the path. And so what we see is that this person, through this compromise of their landline, ends up losing control of their email accounts and of their mobile accounts, and then of their bank accounts. And what happened with this person was that the actors were very sophisticated. They built up a catalog of all the various accounts they wanted to attack, and then on the day they did several things at once. They opened credit cards, but probably the most damaging thing they did is they wire transferred money out of this person's investment accounts. And whenever, and to give you an idea of the sophistication here, whenever the bank called to verify the wire, because these were very large wires and they were anomalous, and the bank's policy was, okay, we're going to call the person at their home number and verify this wire. Whenever they did this, of course, the bad actors controlled the phone. And so what they would do is they would initiate the wire and then reroute the phone to their own control until such time as the bank had called and they verified the wire, and then they would switch the phone back. And in this way, the person whose accounts these were was not made aware of the fact that all these things were being taken over, because the bad actors were very careful to make things appear normal to him, until of course they didn't. So this was a case that we helped work. This person lost tens of thousands of dollars and weeks of work, and had to go and deal with damaged credit reports and law enforcement and all these things. And that was just one compromise. So a compromise is, while we talk about the numbers, we should be keyed in as security professionals to the fact that each one of these is a very painful story for whomever is impacted. All right, so I want to talk about 3 technologies, and then we're going to get into a demo. The first thing I want to talk about is MultiFactor Off. I think that when we look at the fact that most organizations are still using passwords, and that we can see that as something that's going to be going on for a while, there's going to be a long tail on passwords. We have to recognize that there needs to be more incremental assurance on logins in the case where the password has been compromised. Right? So multi-factor authentication is kind of the mechanism there. And I think that you can think of it as being born out of a time when, again, the baby authentication systems didn't think of this as something that had to be done, that had to be intrinsic. We now think of as multi-factor auth capabilities as being intrinsic. And an example of this is that for our, more than 600 million daily users or monthly users for our consumer system, all of those people get multi-factor auth support for free. Right? If we think there's a problem, we will challenge by calling their phone or using their push notification application or whatever. So in enterprise, there was a time when you had your Azure Active or your just Active Directory on-prem, and then you wanted to add multi-factor auth to it, and you had to go buy a third-party provider. In Azure AD, we really don't think of it that way, right? We think of multi-factor auth as something we just want to do, especially for the people who are Azure AD customers. And so as we look at that, you'd say, all right, what do we need to make happen? Well, one of the first and most important things is you've got to register your users. One of the things we're trying to say with Azure AD is there's really no excuse not to, right? We've given you a system. It's a great system. It works well. You register your users for multi-factor auth so that you can turn on these policies, and when there's a risk, you can challenge, and your users are ready to respond to the challenge without taking a big productivity or help desk hit. So MFA is a well-vetted system. Azure MFA is a well-vetted system. Supports mobile apps, which again, strongly believe is the better way to go. Phone calls or text messages are also supported. While I have talked about the fact that we are seeing code phishing and that we are seeing some intentional targeting of phone systems as a way to break MFA, it is important to understand that statistically, the multi-factor auth systems that are phone-based are incredibly strong. They are far, far, far better than password alone. So while I would say you can do better, which is go to mobile apps, do something. And if phone calls are what works at your usability point as a way to get started, then absolutely do it. The next sort of step above this, which really like to see people get to, is where we get into intrinsic multi-factor authentication. So the work we've been doing with the FIDO Alliance and the Windows Hello, Windows Passport is a great example of this, where we have a strong device-rooted certificate. So we have that sitting in the TPM, and that when you log in, you're going to log in with either a bio indicator or a knowledge gesture like a PIN. And those two things together actually are 2 factors, right? And it's very strong. Like if it's intercepted on the wire, it doesn't help anybody, because what you're seeing here is just proof that it is the right user on the right machine. What's stored in the cloud in this case is essentially the public key, and there's very, very little risk of anything going sideways there. This is a great, great system to move towards, but again, passwords are well entrenched in our sort of digital culture, and it's going to take a while to move off of them. But I would encourage you strongly to look at something like Windows Hello as a go forward to and start moving in that direction. We also have people who are using smart cards. It's very, very strong, but again, there's usability problems. Not every app can take the smart card off. Multi-factor authentication, I'll get off the soapbox, but really important you have a solution there if you're using passwords and that you have your user base registered ready for it. We've seen nothing but good come out of our efforts to proof up our user base. We have the most aggressive proof up policy or multi-factor authentication registration policy in the consumer industry. We force users to do it or we won't let them log in. We've actually had increased customer retention out of that, vastly reduced support costs out of that, and most importantly, the risk to the users who are multi-factor authentication registered is lower because they can be challenged more aggressively and we can be more sure that we're dealing with the right person. So the second technology I'm going to talk about is conditional access. This went to general availability on the 27th of July, which I'm really psyched about. And conditional access is a system that lets you look at various conditions of a login and beyond and look at, say, all right, we know that basically this user is allowed to use this application and that we believe that they're the right user, but what else is required? And so we can take things like user identity, device information, and I'll let you look at the slide, the application that we're going to and how sensitive that application is, and then other things like user location or risk, which we'll talk about in a minute, and all those become input conditions to say, do we need more for this login to work? Conditional access allows us to make decisions about, whether we should allow access, block access, or do we need more. And then the third thing I'm going to talk about is identity protection. And the reason I talk about these three things together is because I think of identity protection as being sort of the view and the dashboard over the risk analysis that happens. But all of these things will fit together into one story. So identity protection provides a consolidated view of risks in the environment. I'm going to demo it, so I won't talk to it too much here. And provides those risk scores, and the most important thing about it, in my opinion, is that it makes those risk scores available to the conditional access policy engine so that you can automatically respond to threats. And that's an extremely important thing to do because the longer you allow the threat to be detected but not acted on, the better chance the attacker has of getting a toehold in your environment. So sort of fitting these things together, identity-driven security, we have a user who's ready to do multi-factor off. We look at the conditions of their login. We can make decisions on whether to allow access, block access outright, or do a multi-factor off challenge, and increasingly we're going to allow more and different types of things that can happen there as far as the I need more. We'll save that for a different webinar. And then of course get access to whatever application you want. An important thing to understand about this is not just Office 365, this is not just cloud apps. With a Active Directory, Azure Active Directory application gateway, on-prem apps, custom apps, cloud apps, Office 365, whatever, they can all be set up to single sign-on with Azure AD. And as soon as that is the case, whether that's through federation or through direct login to Azure AD, you get access to all of this control. And these are not separate things, they're just capabilities in Azure Active Directory. They're the security capabilities cooked into Azure Active Directory. So once you have that set up, there's a few other things that are worth knowing about. Understanding what Shadow IT is doing, so you can help bring those other apps under management is a key thing. And so Cloud App Security and what we have is Cloud App Discovery are helping you do that. And then because there is a chance that some attacks will get through and that some accounts will be compromised, it's very important that you minimize the number of accounts that are admin capable. In other words, you want to have as few accounts as possible where admin access is present. And privileged identity management will help you do that. All right, so enough talk. Let's dive into a demo. All right, so what I'm showing you here is Azure, internally we call it Ibiza. It's the new Azure portal. I guess I want to give a shout out to my colleagues. The Active Directory portion of that has just gone to public preview today. Or I think it might have been yesterday. So go try it out. It's very cool. Lots of hard work went into it. We sit inside of this environment, this new portal environment for Azure. And one of the neat things you can do is you can create customized views. So I've got a launch view here for Azure, which includes identity protection and privileged identity management. We're going to focus on identity protection for today. So I want to start off with kind of a high-level tour. There's 3 things that are happening here at a high-level tour on the dashboard. The first one that we're going to show you is users who we believe are at risk of being compromised, right? These are users where we think that there is some likelihood that the user's username and password or credential, if it was a smart card, is in the hands of the wrong person. And this is either because we've discovered it in terms of hard evidence. For example, we found a paste bin where the username and password pair were present, or because through a series of actions and weird logins, we say, okay, we really think something's wrong. A good example of the latter is if something we call geo-hopping. If an attacker knows they have your password and they're being stymied by our risk detection systems, one of the tricks they use is they jump around. They'll take a botnet and they try to jump around in your geography until they find a subnetwork that works, that is close enough to where you work or where you live to let the system let you through. So that geo-hopping behavior to us is a very strong indicator, and with all these things we measure outcomes, and the precision on this one is extremely high, that a bad guy has your username and password. So it's time for you to change your password. Even though multi-factor auth can defeat that initial login, when we see that one of the 2 factors, in other words, we've got the knowledge factor in your password, if we see that factor has failed, we need to get you to reestablish a strong first factor, right? So that's a thing that we can do in that case. Second area we just talked about a little bit is risk events. Risk events are anything that we see about a login or about a user that we say indicates a problem in the account. And here the risk is not that this user is compromised necessarily, but that the session is an attacking session or a compromised session. And then the third major area we'll talk about is vulnerabilities. And this is really areas where you can improve your security posture by addressing a configuration item in the system. So when you look at something like users that don't have multi-factor authentication, I think I've harped on that enough, that's called out here as a vulnerability. When you have too many global admins, that's called out as a vulnerability. Now, the privileged identity management thing that we talked about before gets you into that, how do you manage having too many global admins, how do you do just-in-time access, and all of that fits in here in a way that as we develop other security features not just in Azure Active Directory, but in our partner products, we're going to help identify items where we have problems and then help you fix those. So each of these vulnerabilities goes right into a, let's get it fixed for you. So if we drill into this one, for example, without, users without multi-factor auth, we immediately pop up a frame that lets you go ahead and configure a policy to actually require Azure multi-factor auth registration. All right, so let's go backwards now and talk about risk events. So, and by the way, if you're, I encourage you to go to the marketplace and just type in identity protection, and you can play along at home. We have had virtually no tenants who have tried this and not found something they were happy they found and were able to resolve. So risk events here here's a few examples of risk events that we expose. This is not our complete list, to be clear, that we have now, and it's important to understand that we have an entire team that's job is to find and synthesize signal. So we're constantly looking for new elements. What have we missed? We have a team that is focused on just figuring out what the machine learning system has missed. So let's talk about the ones that we see here. One of the ones that we see here is impossible travel, right? So as you drill into impossible travel, you can see that, well, right now the demo gods have struck. So impossible travels is going to show us cases where, for example, I'm currently in Seattle, Washington. If I simultaneously logged in Bangkok, that would be an issue, right? So here's some examples of this popping up. I'll scroll over so you can see it. So, Alvin is in Seattle and Santa Monica at basically the same time, and you can see, here that he got there in very, very short order. Now, the thing that's interesting about this is that you can actually go through and dismiss things. You can ignore, mark as a false positive, and you can train the system. So it's a way that you can involve yourself in training the system if you want to. Most of the time, the system will actually self-train, and the way that we do that is if you have a policy that requires multi-factor auth, then when we see a successful response to a multi-factor auth challenge, we can automatically train the system. It allows us to, and vice versa, right? If we see challenges that consistently fail, we can say that we are right in those cases. All right, so the next one I want to show you is leaked credentials. Leaked credentials is a very powerful report. These are cases where we have actually discovered the username and password pair on the web. Okay, these are all seeded. Okay, so this is a demo environment, but we do process many millions of accounts per day, and then of those, we'll see a certain number that will match up. So again, about 1.5 to 2 million accounts a day we will detect and mark as fully compromised. This gives you the insight to see what we see. So for example, if one of your users was using Dropbox, and not with single sign-on, but separately to manage, say, corporate files, they might think to themselves, well, I've already got an email account, I'm doing this for work, so let me just use my work email. And I hate thinking up new passwords, let me just use my old password. And at that point, your username and password for your corporate environment is now at Dropbox, right? Dropbox, recently breached. Now those accounts are out there. As those hashes fall, we see that your username and password pair for your user are now available on the black market. Our researchers might find them there, or we might detect them on the first attempt to use them against our system. An advantage of us having a big consumer system, and our consumer system allows you to use any email address you want when you sign up, is that attackers know that they might get some email accounts or an Xbox account or a OneDrive account out of any attack they make with any URL or with any domain email against our system. So they do try these big batches against us. And as they attack against our consumer system, we're able to detect the attack on the consumer system and then pick that up and warn you before any attack happens against your enterprise. So it's a very, very important actual symbiosis between our consumer systems and our enterprise systems. So the next thing I want to talk about is sign-ins from anonymous IP addresses. Anonymizers, I'm a big privacy advocate. I like the technology in Tor. However, we should recognize that something like 94% of logins from Tor, the studies have been done on this recently, are malicious. It's a rare employee who wants to do their work using Tor. Whether you're using one of the sort of good guy Tor systems, which I'll demo here in a minute, the Tor project is a very nice privacy project, or they're using a darker web version of the same thing of anonymizing browsers or anonymizing IPs, our systems are able to pick those up and protect you against them. So these are cases where we've seen people logging in from Tor browsers. All right, so that's a bunch of signal that we can deal with. Those signals can combine together to create user risk. And so here what we do is we have a machine learning system that basically looks at how these various signals combine to indicate the probability that that user's credentials have been compromised. And so as we go through, we can see my risk level is set at medium because I've had 20 risk events, and then we can drill in to see what were the specific events on my account. You can go through and reset my password in real time, right? And this is, not a crazy thing to do if you think that the user's at risk. But the issue here is that between the time we notified you, the time you got to a computer, did your research and decided to do this password reset, too much time has passed, right? It's enough time for an attacker to get a toehold. So what we'd really like to do is get to a place where we have a policy that enables us to respond in real time. So we're just going to go show that on sign-in risk real quick. There's an equivalent user risk policy. And so here what we have is a sign-in risk policy that says when we see a risky sign-in, and here the sign-in risk is medium or higher, we're going to require multi-factor authentication. Okay, so a fairly simple thing to do. We do give you an impact assessment to show you kind of how many logins would be impacted by this policy. Policy's turned on, okay, and so we'll go ahead and do a quick login to see if everything is doing what it should be doing. Now, I have confidence in it. The Tor network piece of this is a little bit slow because it's going to be jumping all over the world to anonymize itself. So we'll go to office.com, And we'll do a quick sign in. Okay, I said quick, but it's Tor. So it's quick, but it's hopping all over the world. There we got our connection. If you see what's happening here, right, we went from here to France to the UK and back to France, and then finally went to office.com. There are some pages that use the IP to localize, and it's kind of fun to go to those, get everything in the wrong language. All right. All right, and so what you've seen is that we detected the Tor browser in real time, and the end user experience is just, hey, look, we saw something unusual about the sign-in. Looks like you're signing in from a weird environment. Let's verify your identity. And then what's going to happen now is my phone's going to ring, and if that was a false positive, like if I was a user doing research and just choosing to use Tor, or if I was, traveling and the locations thing had a false positive, I have a relatively quick way to just resolve that in real time. I'm not going to answer the phone here. We're going to leave our assumption that this is a bad guy. Of course, that data now shows up in my user view, so I can see that I can see that event happened. And then finally, the last thing I'm going to show you in the demo here is just briefly, we have a very similar thing for user risk. So when you see a user who is at risk, you can do this, requiring a password change. And so the flow here would be, we would say, look, we've seen something wrong with your account. We want you to do a multi-factor auth challenge and then do a password change. This password change in this environment always requires a multi-factor auth challenge first. But that self-help reset, self-help remediation, the account is locked until it happens. From the millisecond we detect the problem, that account will require MFA and a password change if you set this policy up. And so you would just set this up by saying, include all users, where user risk is medium or higher, require a password change. So it's fairly simple to do, and it's a lot of protection. All right, with that, I'm going to jump back into the very last slide here, and to say that this technology is part of a suite of technologies that allow us to really provide soup to nuts protection. The stuff I showed you here is how we think about protection at the point of login to Azure AD. You can also look at what's happening on the session using Cloud App Security. You can think about how documents are protected on the wire using RMS and Secure Islands. ATA looks into your on-premises environment and provides insights into possible attacks in that environment. And then Privileged Identity Management helps you reduce the level of exposure you have if an account is compromised by reducing admin privileges to just in time and just as needed. So that's kind of the whole landscape of the stuff that we're doing in the security story. So I've really been focusing just on the identity protection piece, but it fits right in with the kind of overall story of how do you follow attackers as they try to move through your environment and really disrupt them at every turn. So with that, I think we have about a minute for questions, so I'll throw that out.
Impeccable timing, Alex. Any questions out there? I did respond back to the questions about the presentation availability. We will be publishing this on the Oxford website.
All right.
No questions? All right.
Okay, well, you guys are making it easy.
Yeah.
All right, well,
we're getting some nice comments there, so thanks for the presentation comments.
All right, I have one question, which is, are identity protection capabilities available for user stores that are not Azure AD? And the answer is no, this is really intrinsic to Azure AD. This is a set of capabilities that are built into our authentication pipeline. So literally, when I talk about real-time evaluation of logins, that's happening in our really in our token servers. So it's happening, right as we do the username password comparison or the username cert comparison. And we are, we would support something like, if you have ping and you wanted to do a federated login, but at the end of the day, we have to be an authority on that chain or we can't do the assessment. For the folks who said thank you, I would say thank you back. I really appreciate you guys checking it out. I do have one other really quick announcement, which is that we announced our GA, and we're going to be going to general availability with this product in 2 days, so on the 15th.